So let's look at example number 3 in which we deal with projectile motion. So suppose we have a disc thrower that throws a disc at an angle of 35 degrees and a velocity of 15 meters per second. Now we want to find the distance the disc travels if the disc left the hand 2.1 meters above the ground. So this is our illustration. Now our person lets go of the disc 2.1 meters above the ground and they release the disc at an angle of 35 degrees and a velocity of 15 meters per second. Now we want to find the distance our ball travels, or displacement of our disc, not ball, that goes from this point, our initial point of 0, to some point here. So we want to find this displacement here. So there are many different approaches that we can take in solving this problem. But we're going to take the following approach that deals with 3 steps. So we'll find our answer in 3 steps. So in step 1 and 2, we're basically going to find the time it takes for our ball to travel that distance. And then we're going to multiply the time by our horizontal velocity, and we'll find our distance or displacement along the x-axis. So let's look at our illustration for step 1 and step 2. In step 1, we're basically going to make the following assumption. We're going to assume that this point, 2.1 meters above the ground, is our initial point. And we're going to make the assumption that this line represents our ground. So at this point, our height is 0. And we want to find how long it takes our disc to travel from this point, which is actually 2.1 meters above the ground, to this point, which is also 2.1 meters above the ground. So we simply want to find how long this parabolic pathway takes. So that's step 1. In step 2, we're going to find this last section here, or how long it takes our disc to travel from 2.1 meters above the ground to our final ground. So let's go to step 1. In step 1, we're going to use the following formula. This formula tells us the following. Our initial velocity at this point, pointing upwards, so our vertical component of velocity at this point is simply 15 meters per second multiplied by sine 35. And what is our velocity at this point? Well, at this point, our velocity has the same magnitude, but it's pointing in the opposite direction. So at this point, our velocity is negative 15 meters per second times sine 35 degrees. So we know this guy, we know this guy, and we know what our acceleration is. It's negative or positive, depending on what you assume your condition to be, 9.81 meters per second. So we plug in our values and we get the following. And now we basically take this guy, we bring it over to this side, and then we divide by 9.81 meters per second, and that gives our time. So 15 sine 35 times 2 divided by 9.81 meters per second gives us 1.75 seconds. So it takes our disc to travel 1.75 seconds to get from this point, 2.1 meters above the ground, to this point, 2.1 meters above the ground. So now in the second step, we want to find what the remaining pathway takes. How long does it take the disc to travel from this point to this point? So this is the formula we're going to use. Why? Well, because we know what our y final is. Our y final is 0. We know what our y initial is. It's 2.1 meters above the ground. We know what our velocity is at this point. So our initial velocity, we know it's simply negative of this amount. Because remember, whatever our guy begins with, our guy must end with at this point, at this x-axis, at this line. So at this point, it's the same magnitude but negative direction. So it's negative 15 meters per second times sine 35. The time, we don't know. That's what we're looking for. Plus 1/2 acceleration, we know, is simply 9.81 meters per second squared, and the time is what we're looking for. So what we basically get is a quadratic equation. So we have to use the quadratic formula to solve for our second, to solve for our time. Now we get two answers. One is negative and one is positive. Remember, our time is a scalar, so negative time doesn't make sense. We reject negative and we accept the positive solution. So our time we get is 0.217 seconds. So to find the total time, we simply add this time to this time, and we get 1.97 seconds. So we add 1.75 to 0.217, and we get this result. So in step 3, we use the following formula to solve for our displacement. So we're looking for displacement, so we're looking for the x minus x naught. So this is what we're looking for. This point is simply assumed to be 0. This point we know is simply 15 meters per second times cosine 35. The time we know, we just found what the time is. And the acceleration is 0. Acceleration in the x direction is always 0. So this guy crosses out, and we simply get x equals 15 cosine 35 times the time it takes our ball to travel this entire distance, which is 1.97 seconds. Multiply these guys out, and we get approximately 24 meters.